All right, so for our first section of notes that you have here, I'm going to ask you, which is kind of a really big idea of why we're going to use a graphing calculator, what does it mean to graph an equation? What does that graph represent? You graph equations all the time in y equals form. What does that mean? What does the graph do for you? Why do we have you do this? It should be pretty simple. You've been doing it for years. Why do you do it? Why are you graphing? Yeah. Okay, and what's the connection between solutions and a graph? What does it mean to graph an yes, ma'am?
It's a physical representation of what the graph means.
Okay, so when you say that's what it means, and somebody else mentioned the word solutions, connect those two ideas. How do solutions and math, what math means, how do they kind of work together? Okay, it turns out there happens to be patterns which create shapes. We actually have to go down to a little bit simpler level than that. Anybody taking computer science? Yes, computer science. What is the basis of all computer science? What does it come down to? Two things. Ones and zeros. And what do ones and zeros represent? Ones and zeros. Binary for yes and no's, correct? Okay, so we're at this real basic level of zeros and ones in computer science, of being yeses and nos, open, close gates, whatever. I mean, there's a lot of different ways that we've used that concept. But now, when you get to math class, believe it or not, the reason why I have to take computer science as a math teacher and be able to teach it as well as teaching math is because it's all related to the same concept. It relates to this. When you graph an equation, okay, you create a physical representation, which was already explained, of all of the solutions. And what makes something a solution is the fact it's the combination of numbers, of x's and y's, that generate true statements. They're unique, specific combinations of numbers that give you true statements. That's what the equation actually is. So when they're like, oh, it's the big deal, we'll take these ninth graders, we'll teach them y equals mx plus b, and we'll graph. Okay, great, they can generate a line, but that line is the combination when you plug them in of x's and y's that give you all the possible true statements. Okay, that's what the graph actually represents. The numerous solutions, or in many cases, infinite solutions. Okay, everything in math goes back to true and false. Yes and no. Does it work? Is it legal? Doesn't it work? Is it illegal? And we have to eliminate it. Everything that we do comes back to that. So if we look at our first example, which goes way back to pre-algebra, when you first started learning to graph lines, if I asked you to graph 2x plus 3y equals 18, how would you do that right now without a calculator? 2x plus 3y equals 18. You're going to graph it. What would you do? 2, 3, same 3 people, 4 people. Go ahead. Sorry. You would solve for y, and then you would graph the line, correct? Now, as you've worked through Algebra 2, you've learned that these variables can take on different powers, which will generate different shapes, correct? What is the shape of 2x plus 3y equals 18? You know what shape that will generate?
A straight line.
Straight line. How do you know?
Because there are no powers or absolute values to it.
Right. Power of x is 1, power of y is 1. That's what tells you that this is going to be a line. So in your brain, you should say, well, to graph a line, I transform it into y equals form, and then I graph the y-intercept, I use the slope, connect, draw my arrowheads to represent, going on forever, and I have my solution set. So please go ahead and do that in your notes. So first page, you should have this at the top as the example. Draw a sketch, solve for y. Good to go. go ahead and graph it on the right. There's an x, y axis. You don't have to label it. So I'm guessing if you did this correctly, you would have gotten y equals negative 2/3 x plus 6. You would have graphed the key point of 6, which is your y-intercept, down 2/3, down 2/3. Connect the points, draw arrowheads on the end. Okay, that's going to be the graph of the actual line. Part B to this question asks whether or not the 2 points I gave you are solutions. How would you determine that? How would you answer that question? Don't be shocked because there's more than one way to answer the question. Yes?
You can either plug them into the equation or find the points on the graph.
Okay, so we can go back to that concept of ones and zeros, yeses and nos, and actually verify each of the points. So in the verify section, for example, the first point is negative 5, 7. We know that negative 5 would be x, 7 would be y. We could plug it in for x and y and determine whether or not the resulting equation is true or false. If it's true, then it's a solution point, and if it's false, then it's not. So notice I plugged in the negative 5 and the 7, and I got false. Okay? Now, let's talk about proofs. What I just did was called an algebraic proof. I used algebra through substitution to prove whether something was true or false. Perfectly acceptable reasoning, justification for your answer. Okay, algebraic proof is when you use algebra, substitution, to solve. Okay? We can do the same thing with the second pair. And notice that when we plug in 3 for x and 4 for y, it generates now a true equation, which means it is a solution. Again, algebraic proof. However, if we go back to your drawing that we had here, and we look at 3, 1, 2, 3, 4, what do we notice about the point 3, 4? I just graphed it. What do you notice about it? It's on the line. By definition, if an ordered pair falls on the solution line, then it is a solution. This would be considered a graphical proof. So if you already have a line generated, this is probably the shorter method to choose. So if it says to prove or to verify, your explanation should include whether you substituted or whether you looked at the graph and determined that the point fell on the line. Okay, negative 5, 7 would be somewhere back here, up 7. Obviously, we can see that that point does not fall on the line. It would be in the white space left over, since this is not an inequality but an equation. It doesn't fall on the line, it's not a solution. Okay, that is a graphical proof. Graphical proof. Now we're going to jump into a third way that we're going to start to prove things. And some of you are going to really like this method because it's very quick, which is using the technology itself. So if we take a look, the next thing we need to do is we need to use our calculator. So I'm going to apologize up front. Those of you that are very good with technology and you've used these, this is going to seem like baby steps. Those of you who have never used the calculator or don't know all the menus and stuff, this is going to be a very good introduction to the calculator for you. Now everybody will be at a level playing field. So not included in the notes are the next few steps that I'm about to go over. let's talk about setup of the calculator. So when I turn my calculator on, okay, when I turn my calculator on, I should have a working screen that is plain. If this little box isn't dark enough, if you hit the yellow second button and the down or up arrow, it should make the contrast darker and lighter. The darker it is, the faster it's going to burn through battery. So find one that's comfortable. You have to alternate between second up arrow, second down arrow. Alternate back and forth. So I can make it real light or I can make it real dark. All right, this is your working screen, 2 plus 3, things like that, 2 plus 3, etc., 5. You can do all of your calculations here in this home working screen. Now, the next thing we need to do, anybody in stats right now? Okay, so those of you that are in stats, these are going to be real important for you to kind of figure out, be able to move between these for the different classes. The next thing we want to do is type on y equals. Y equals is right up here, top left. And you want to make sure when you go into y equals that all of your plots are not highlighted. Okay, does anyone have the word plot 1, plot 2, or plot 3 that is like kind of blacked or bolded? You do. Okay, move your arrow up on top of the one that's bolded and then hit enter and it'll turn it off. Got it? Okay. So, those of you in stats, when you come into here, you're going to want to turn those plots off because you will use those plots in your other class. All right? So that's the next thing that we have. You can go in here and slide down. Does everybody have something that looks like Y1 with what looks like diagonal lines? That has to exist for us to graph. The next thing you want to do is we want to press mode. Mode is right here. Okay? And for now, let's everybody go down and let's put our menu to match normal floating decimal, which means as many as it can give you. Switch it to degrees for those of you that are in physics. You won't need to be switching settings and stuff, so degrees will be the easiest. We want function mode, connected mode, sequential mode, real numbers, and full screen. All of those should be highlighted. Does anyone not have that or need help? Okay, so this setup, once you go in and do this, it will stay this way until you change it. All right, that's another nice thing about the calculator when you turn it on and off. If at any time you press a button wrong or you get into a weird menu and don't know what you're doing, you can always go into second mode, which will take you out of wherever you are back to the working screen. Okay, your working calculator screen. Apologies for my voice, by the way. I normally don't sound so breathy. All right, so now let's jump into starting to graph. So if you look at our first example, the first example says to solve 3x minus 5y equals negative 10. The only way to graph in the calculator is to put it in y equals form. Okay? Y equals form. So please go into solving your calc. So you have to solve by hand. All equations have to be solved into y equals. And then we're going to go into y equals the button. And we're going to type in 3/5, 3 divided by 5. Variable button. Plus 2. Okay. This is a new button for those of you right here underneath the word mode. The calculator will only ever show X, but it could represent theta, it could represent T, it could represent A, N, whatever the case. Okay, so we're going to go ahead and put that in, and then we can hit the graph button. Notice it crosses at 2 and has a positive slope. That looks like it's a pretty good representation of what we have. Should have. Yep, that's where we're going next. Okay, so if you look at my calculator, this is what I'd like all of your screens to look like right now. If you don't have that, if you type on the word window, which is right here, window, you're going to notice that my calculator is set up with -10 to 10 for x, scale of 1, so that means I'm only doing whole units, and then -10 to 10 with a scale of 1 also. Okay? This is what's known as, and this is a question in your notes, the standard window setting. If you don't want to take the time to type all these in, you can go into Zoom, and all the way at the bottom, Zoom 6, you have one called Zoom Standard. When you choose that option, either type the number 6 or use your down arrows to select, hit enter, you now will have a screen. You now will have a screen that's the same as everybody else's. This is known as the standard window setting. We will use this probably about 80% of the time. Standard window setting. Now, next skill we're going to talk about is finding intercepts. Finding intercepts. Those of you at Algebra 2, you did it by hand. Hi. Okay. You're going to need a lot of stuff. Let me give this to you. Go online, Ellie, and enter your book number. There is a link for a survey. Thank you. Here. You're going to need this. You're going to need this. Graphing calculator out, please. Huh? What? Well, you're going to need it. Well, online, there's a survey you have to fill out for your book. Maybe. Yeah. All right, so in Algebra 2, we did this by hand. Now I'm going to show you how to do it using the calculator. Okay? The reason I'm going to start it with the calculator is because the x and y intercepts in real-world problems are very important, and they're not nice calculations when we get into equations that are not as simple as, y equals -3/5 x, whatever, blah, blah, blah. So because of that, we're going to use the technology. In order to find the y-intercept, okay, what do we know about all y-intercepts? This is something that we have to know moving forward. What do all y-intercepts have in common algebraically? Every y-intercept in the world.
It's on the y-axis.
Okay, it's on the y-axis, and what do we know about all points on the y-axis?
The x
X
is 0.
is 0, okay? So, here's the deal. This is why I'm going to tell you this, and this is the important part of trying to make this connection with the calculator. The only place to enter x's into the calculator is trace. So trace is where I enter x values. Okay? So when I click on the word trace, my graph is up and I hit trace, what does it prompt me for at the bottom? Here's trace right here. What does it prompt me for at the bottom? The x value. In this case, the x value is 0, so I would type that in. So I'm going to click on trace, x is 0, and then notice it gave me the ordered pair 0, 2. Okay, so in my notes, when it says, how do you find y-intercepts, you need to think y-intercepts, x is 0, the only place to enter zeros is using the trace button. Plug it in and find it. Okay. Questions on that? All right, next thing you're asked to find is the x-intercept. What do we know about all x-intercepts in the world? X-intercepts all have y equal to 0. Okay, so now this is a little bit tricky. This isn't as nice as trace. The only place that we can enter y's, is in the y equals menu. Go figure, right? So I'm going to go into y equals right here. My y1, my first equation, is going to be 3/5 x plus 2. My y2 is going to be 0. And then I can go back to the graph. So here's what I've done. Here is my y1. Here is y2. My y-intercept exists right here where the two lines cross. The calculator will find that point using the command of second trace. Notice I have it written right here. Second trace, take very good notes, please. Go all the way down to intersect, which is 5. This is what your calculator screen will result in. So notice I went into second trace, I chose option 5. It went back to here, and it says, the calculator's prompting you. What do you want for your first curve? You have a choice of all those y1, y2, y3, y4, y5, y6. Do you want y1? Yes, I do. Hit enter. For my second curve, do I want y2? Yes, I do. Hit enter. Now it asks me to guess. So notice I'm moving my cursor over using the arrows to on top of where I think those two lines are going to cross, and I'm going to hit enter. And it's going to give me the decimal -0.33 repeating, comma 0. That is my x-intercept. And no, there's no shortcut. Yeah. Okay, questions on that? Two totally different procedures to find the intercepts. No shortcuts, sorry to say.
Wait, can I just go over what I just said?
Yep.
So you do second trace, and then you go into intersect.
You have to go to y2 first. y2, put in 0. Second trace, choose intersect.
And then it said find curve.
Enter.
The cursor to where it intersects.
Right, you're going to have to hit enter twice, though, because it's first curve, second curve. Correct.
And then the cursor over it, and then enter it.
And then it'll give you the ordered pair. You got it. Okay, part C. How can we use the calculator to see if 5, 5 is a solution? All right, 5, 5, is it a solution? This is exactly the same question I asked you before we started the calculator work. How do we find this out? Well, can you enter an x value? Where do I enter x values? Trace. So can I just go into trace, enter x equals 5, and then see what comes out for y? What if y comes out to 5? What would you tell me the answer is? If y ends up being a 5, is this a solution? Yes. If this ends up being 12, then this is not a solution. So you don't have to plug anything in, you don't have to simplify, you don't have to do anything. If you already have the equation in the calculator, simply just verify it using trace. Okay? That's our first option, use trace. Now, if you want to go old school, since you have a calculator, you can always verify both sides. So you can plug in to the original equation, x and y, Do you get what's on the right-hand side? Yes or no? Third method, which is one that we're going to use moving forward also, is the table method. So if I go into second graph, you all should have a table. Now, if the numbers in your table are not nice numbers, you can go into second window, table set, have it start at a number like -1, and make sure that your increment is 1. When I do that now, and I go into my table, notice it will start at -1 and it changes by a unit of 1. Every time I go in, once I have the setting set up, it will always do that. So is 5, 5 a point on the line? Yes. How do you know? It's in the table. Trace is your fastest. Table method works. Verify both sides of the equation works. It's up to you. Yes, ma'am. That would be why. So you have to put in the 3/5 x and the, yes.
So for the first one, where it says trace, like I'm confused. Where you just
Okay.
do trace.
All right, if you want the calculator to trace,
Yeah.
right? Basically, here's what you need to think of. You entered an equation, right?
Yeah.
For y1. So your calculator has this screen and it has an equation to it, right? So when you hit trace, you need to tell the calculator what you want it to focus on. So that's why when you hit trace and you type in a 5, it's going to go to the x value of 5 on the line itself. You know what I mean? Like you're directing the calculator where to trace at. Good? Question. All right, now, here's where we can start to see, this is where I start to see whether or not the connections that I just taught you are holding or not. Or if you're just doing what I'm doing because I'm telling you to do it. Here's what I mean by that. Same exact procedure. So I gave you a new equation. 7x plus 3y equals 21. How do I put that in the calculator? We're on example 3. Yes, ma'am.
Solve it by hand first, then you type it.
Solve by hand, put it in the calculator. So I'm going to go to my y equals. I'm going to clear everything out. I'm going to go up here, and I'm going to say, okay, y equals -7 divided by 3x plus 7, maybe. Solve for what? Okay? I can look at my picture and say, oh, that looks great. Look at that line. Everybody get that line? Do the work, solve for what? Watch your signs. Ellie, I'm recording this, so it'll be on YouTube. You can go back and rewatch everything. Make sure your calculator's set correctly to do tonight's homework. Okay, here comes the big aha moment. I'm going to ask you to fill in some ordered pairs. I gave you x. Where do you enter x's as commands in the calculator? Where do you feed the calculator in x's? Trace. So go to trace. Type in -2.5. Hit enter. And I got my answer. 12.83. Same idea as finding a y-intercept. Yes, ma'am.
When I hit the graph button after I type in that equation over the y equals, it says errors.
Okay, I'm guessing it's your negative sign. Go Go to your y equals. Okay, now, part 2 is going to be the harder one, not quite as easy. Where do I feed in y's to the calculator? There's only one place. Where do I enter y's? I'm going to go to, not trace, where do I feed in y's? Y equals. So go to y equals. You're going to go there and you're going to say, okay. Go to y2, type in 1.5. Then I look back at my graph. Now I have a new line there. What do I do with the new line? Second trace. Option 5 is intersection. Because what I want to find is this point right here. So now, is my first curve y1? Yes, hit enter. Is my second curve y2? Yes, hit enter. And tell me my guess. So I'm going to slide this little sparkly guy. I call him the shiny guy because he like pops around a lot, or she. Right on top of where I think the intersection is, or pretty darn close. Hit enter, and notice here's my y value, here's my x value, 2.357. I would say at least 2, 3 is better. At least 2, 3 is better. Yes, I get it. Y equals is a lot more work. But you need to know that's the only way for the calculator to do it. There are no shortcuts. All right, we have 4 minutes left for me to show you how to graph in the calculator 4 different functions. Okay? First function we want to talk about is finding intersection. Wait, we've already found the intersection. To find the intersection of 2 different shapes, we're going to go into second calculate. Okay? And we're going to use intersect. But what do I need to enter into the calculator first? In example 4, go to y equals, clear these out, and enter the 2 things. So I have a parabola, x squared plus 3x minus 1, and x plus 2. All right, now, here I stand, first day of lessons, 6-foot white girl, purple sweatshirt. How many intersections are there? Look at the picture. How many intersections? 2. So I'm going to take my purple marker, matching my shirt. 2 intersections. We have to go in and calculate twice using intersection. The difference is, the first time I'm going to guess this point. The second time I'm going to go in and guess this point. So I have to go through the commands twice because I have 2 different points. So here's the way I do it. Go into second trace, calculate, choose option 5. First curve is this. Second curve is this one. And my guess, I'm going to slide it all the way down here. This is going to be my guess number 1. Notice, here's the ordered pair that I got. So I got -3, -1. That's my first intersection point. Yes, ma'am? Yeah, because we're only ever going to have 2 curves. Enter, enter, and go from there. Now, because I have a second intersection point, I'm going to go into second calculate, intersect. Again, first curve, good. Second curve, is y2. But now my guess, I gotta move from this shiny spot to this one over here. I'm gonna move right up the line. I'm gonna say, calculator, focus on this one. I notice now I get 1, 3 as my other point.
Does it matter what order we do them in?
The key is the focusing of the calculator. Just like with trace, the other one, you have to tell it where to go. It doesn't know. Questions on that?